My name is Hanisha Vemireddy and I'm a PhD student in the Industrial Engineering Department. The topic of my thesis is the role of test locations in early stage plant breeding with a focus on identifying discriminating locations and extrapolating performance to locations that have not been observed. As we all know, there is a constant increase in the population in the world, and with the same amount of limited arable land and water, there is a need to meet the ever increasing food demand. So this is the constant problem that the agricultural industry is trying to answer, and they're constantly working to maximize the amount of food we gain by breeding seed varieties with the strongest and the highest yielding varieties. Each breeding cycle is super long for about 9 to 10 years and often requires vast testing resources. Um, so once every year, hundreds of thousands of varieties come into the field testing stage where each of the varieties are tested in only a few number of locations, and the breeders have to make a decision of whether or not to keep the variety in the program. And often discarding a variety from the program is a permanent decision. So something that plays a very crucial decision in making this is the locations in which each of these seed varieties are planted, as they help in understanding the performance of each of the varieties, or they help in quantifying the yield. So this thesis mainly addresses two problems. In the first problem, for every variety, like I said, it's only tested in a very limited number of years, and say we want to predict its yield in a locations where it has not been observed. But if we can identify, similar varieties or related varieties, we could expand our target data to these observed environments where these related varieties have been observed. But we have to account for the fact that there is an actual performance difference between the target variety and the similar variety that is being considered. And this is often done by taking advantage that similar varieties are often planted together, or they're planted along with the same varieties. The second problem that we addressed is that in early stage experiments, the goal is often to pick the variety that is better rather than having a good estimate of the exact performance of these varieties. So thus, if we can find locations that can be used to make the correct selections with high probability, even if that means by exaggerating the performance to see exaggerated differences between each of the varieties, rather than to estimate the mean difference with precision. So breeders would want to plant the varieties in discriminating locations to help improve the ranking between each of the varieties.